All right, welcome to Test Spies. Let's talk about it a little bit. So test spies are like, I think where the difficulty of testing sort of like ratchets up just a little bit. Because like the idea of if I put this input into the function, do I get this output out? That's easy enough. I think most people can kind of wrap their heads around that. Spies are where it like gets a little bit trickier. So to simplify it a little bit, let's think of spies this way. So if you pass a function into a unit test, really, I'm going to take that back, any test, it should be a spy. So as far as like rules that work most of the time, that's a fairly good one. So for passing numbers, strings, objects, anything else, hey, no problem. Just write it. If you're passing a function in, make it a spy. Don't write out the function. So who can think of why? Why would I want you to not write out the function? Do a spy instead.
Is it because it's more predictable?
Yes, absolutely. If you have to write out a function to pass it in, all right, where does that function get tested? So we want as little logic as possible in our test, because that's one more thing that we could get wrong, one more thing that we could break. We want it to be like pure syntax. So writing out a function makes one more thing that we could get wrong, and then our tests become a little bit less reliable. Because these functions that we pass in, they shouldn't be general. If they were general, we would need to test them too. We only need them to work in like that specific circumstance. So we're going to look at a couple different ways that we can kind of play with that and make that predictable. But that's the idea. If you're passing a function into something that's going to be tested, make that a spy instead. Ask me some questions about that. All right. How do I make a spy?
No
It's
idea.
chess.fn.
That's it. That evaluates to a spy, which means that this is a what?
Expression.
We're starting to get it. We're just starting to get it. Just.fn, if you invoke it, evaluates to a spy. Now, there's a couple cool things that we can do with spies. Simplest of which is just return a value. So if I make a spy and pass a function into that, whatever gets returned from this function will be returned whenever the function is invoked. So if I'm saving this in some function, and that returns 14, whenever some function is invoked, it just returns 14. No other logic to it. Who can tell me the vocab word for using a spy like this? Also starts with an S?
It's a stub.
Stub. Very good. No logic to it. It's still a function, so if the thing is expecting a function, it'll work just the way that the function normally does. We can even pass in arguments and stuff. But instead of having all the logic for how it calculates 14, it just hard codes the response. And part of the reason for this is that we're trying to test stuff in isolation. So if I have all of these different functions and this function gets passed into that function and that function gets passed into that function, it's really easy to end up in this scenario where if I want to test one of them, I inadvertently end up testing all of them. That sucks. So spies are one of the ways that we can get some isolation on this. So if this thing ordinarily would get passed into that thing, instead of doing that, I pass in a spy. And now it doesn't even matter if the logic on this is good, bad, or whatever. I pass in the spy and I just hard code the right value. So then testing this thing ends up being, assuming its collaborator, assuming this other function is coded correctly, does this work? And that is how we can isolate this from everything else that it works with. That's why we use spies.
Excuse my ignorance here, but does a spy go into the regular JavaScript file or does it go into your test?
No, great question. It goes into the test. The JavaScript file that is like consuming this function is doesn't know that it's a spy, doesn't care that it's a spy. From its standpoint, it's exactly like the real function that it would ordinarily get. But using a spy in the testing framework lets us examine how that function got used and then make assertions about it. More questions about spies so far? Two other things that you need to know about spies. One is matchers. A spy, you can pass that into expect, and then there's a set of matchers that work with spies. So you can do things like expect some spy to have been called. And then there's a ton of variations on that. You could also invert that, expect that not to have been called. There's ones where it's like to have been called with this argument, to have been called 3 times, that kind of stuff. So that's another thing that you can do with spies, is that you can make assertions about them. And I think I wrote a pretty good guide to how those work in the LMS. Let me pull it up. Okay, so these are your go-to matchers with spies. To have been called with, to have been called times, to have been nth called with. So that's how you can assert on a spy. Then the last thing is, so we can stub like this. We can mock like this. And then there's also, we can also do this. Where we say like, all right, the first time it gets called, I want it to return this. Second time, I want it to return this. Third time, I want it to return this. Also works with promises. So if the thing you're passing in makes a fetch call or something like that, mock resolved value will mock whatever that promise resolves to.
What's the difference in the mock return value and then the mock return value once?
So the way that this will work is the first time you call some spy, it'll return that object. Second time you do it, it'll return that object. Third time you do it, it'll return that object. Fourth, fifth, sixth, seventh, 452nd time, it returns that. It's like a default. That's the same thing. If you pass the function in and then chain these, first one, second one, third one, fourth one, fifth one, sixth one, seventh one, 452nd one. All right, enough jibber jabber. Let's get our hands dirty. So I am going to send you a link. This is in Zoom chat. Go ahead and fork this one. All right. And then this teeny little plus sign over here next to yarn start. Hit that. To unhibernate my container.
Does it matter that mine says a 502 bad gateway?
Nope.
Okay.
It's because there's nothing visual for it to show. So like there's a browser there, but this is all just in Node, so it doesn't matter.
Gotcha.
How do you fork again in Code Sandbox?
This thing right up here. It's right next to the create sandbox.
I don't have that.
What? Are you logged in?
Yes.
Yay.
I had a pop-up that came up at the bottom that said if you want to make any changes, you need to fork it, and it just had a little blue button on the bottom.
I see it.
You got it?
Yeah, I see it. Thank you.
Excellent.
Thank you, John.
Of course.
I still can't find anything on mine for doing that. Maybe try reloading it and see if maybe the pop-up comes up.
Watch the screen share, Matt. Let's work through it together.
Okay. Oh, there it is. Wait. Now I see the pop-up.
right. Anybody else having
Okay.
trouble?
I'm in.
All
And then
right.
what was the little button you said we have to
This
click
little
on?
teeny tiny plus button kind of next to yarn start. That'll give you a
Okay,
new
gotcha.
terminal.
Got it.
And you can, since we're not using this browser at all, you can just pull this all the way up. And if we npm test, hey, cool. So you should be able to get this far and see that error. And this is our higher order function build and burn from a couple weeks ago. I have all the finished code in there, but I deleted all the tests. All right, give me a thumbs up if you got this far. Yes, 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 yes. Sharon, how you doing?
Making me fork it again. I already forked it, and then I went to type in the npm test, and it went back to yours, and I have to fork it again.
I want you to screen share and let's work through it together. No coder left behind. All
Because
right.
the test went through.
Okay.
So never mind.
Still not seeing the error though. Were you able to run npm
Oh.
test?
Hold on, let me share it again.
It
So when I
looks like
forked
you
the
hadn't
test-
started. It looks like you hadn't started your new terminal yet.
Yeah, so if you go up to the plus sign over there, yeah, let's see what happens if you run npm test.
Yeah, that should do it.
You're beautiful! All right. So let's figure out how we would test some of these. Let's start with map. That's an easier one. So if you go to this test file, say I wanted to write a test for map, which is like map returns a transformed item when given map returns a transformed array of items when given a single item. So that'll be the test name. Then in this function, so when you get this far and you get stuck, you go, okay, arrange, act, assert. I need to like get the app in the right state. So that's this like map function up here. I got to figure out what values I want to use. All right, so it'll be single item array. And then just an array with 1 in it. So that's our setup. That's a range. Our act. Ooh, and then we also map takes in an array and then a transform function. That's where our spy is going to come in. So we're going to say transform is just.fn. Now we're going to do the like doubling thing. So we can tell it to just return 2 like that. So
I won't accept the FN. It keeps auto-completing to focus navigation event.
Uh-oh. Well, why don't you screen share and let's take a look.
I was gonna say press escape to get rid of Emmet's suggestions because we're using jest and not typical JavaScript.
Yeah, were you
So
able?
type
Can you
FN escape. There you go.
Yeah, then just put the parens. Yeah, there you go.
I'll leave you alone, I promise.
No, I don't want you to. I want you to. I want all of us to get to the destination together.
I had been clicking out every time, so thank you for that suggestion, John.
Yeah, it was early on in the queue. I think Scott was the one who's annoyed to death at different suggestions. So yeah, just escaping out of Emmet allows you just to type code when, hey, we're using something that Emmet doesn't have abbreviations for.
Cool. So here's my setup. Got a one item array. I've got a stub that just returns 2. So now my act transformed array equals calling map with single item array and transform. So then I want to assert. So I'm going to expect that transformed array to equal, not to be, to equal 2. Oop, I haven't seen this test fail. So I'm going to make it 3 and hope it fails. You can do this to make it watch the tests. Or it's got a second set of dashes in there. Hey, very nice. It was expecting 3, it got 2. I wanted it to be 2 though. So if I fix that, now I got a passing test. Get this far, your screen should look like mine. The syntax kind of looks crazy, but there's no logic in this. Not really.
Mine is passing when I say it should equal 3.
Uh-oh.
Yeah.
Let's take a look. All right. It's because your test isn't saved.
So it wasn't running this essentially.
It wasn't running the thing that you're looking at.
Well, that's dumb. All right.
Hey, nope. So let's walk through what we did. We assigned a value. This looks kind of wild, but all it is like a standard syntax, and it just returns a single value. We invoke the thing that we're testing, make an assertion about it. No logic.
I have a question.
Yeah.
So for the const transform, the just FN, so that's not doubling our single item array. It's just returning 2.
It's just returning 2. It doesn't even acknowledge the thing that it's given. So when this map function calls transform item doesn't even get looked at. It's just going to get 2 back every single time.
So like, then what's the? I don't want to say what's the point, but like, what's the point
Sure.
of like testing?
So imagine it's more complicated than that. Imagine this transform. Here, let me pull up a real one. Okay, so this one is a mapping function that takes in a performance and adds the original post slug to it. And it has to pull that out of context and a whole bunch of other things. So if I want to test something that uses this, then, oops, if I want to test something like this function right here, then I need to write out all of that logic in my test. Okay, how do I know that I got that right? How do I know that this was supposed to be spread instead of just left alone? There's a surface area for mistakes there. There's no surface area for mistakes with this. There's nothing I can get wrong about that.
Okay, thank you.
Another way to think about that. If I'm testing something that runs through a pipeline, and I want to test, I don't know, this part of it, rather than have it actually work with these, I can just kind of fake them out. That allows me to test that this thing works all on its own without also needing to make sure that all of these other things that it works with also work. I can just do fake implementations. Now, like, it's always giving you back the same thing, but this test is only one specific circumstance. That's why I can hard code the response. When we do another test where it tests two things, that's not going to work anymore. So I can write a hard-coded implementation that works in this one situation without needing to write a general solution to it. And a good example of that is things like, remember our floating point error from yesterday where, oh yeah, it's a sum function that takes two numbers and adds them together, but it didn't work with floating point math. All right, well, like maybe I want to isolate that so that I'm not also testing JavaScript's floating point math. Can it just give me a 0.3 back? It's a way to isolate problems.
I was going to say another example is like think upstream. Say someone else is writing the code that's going to go into yours. Well, they don't have a working function yet. So if we mock their function,
yes,
and pull in, just say, okay, I know they're working on it. I know when they're done, they're going to output something that I want to see, but I don't have it right now. I can't call it. I can't do anything. Let's just pretend they gave me the correct answer and now feed it into mine.
Love it. And then if it doesn't work, this serves as your documentation. You go, all right, well, it works if it returns 2 in this situation, so why isn't your thing returning 2 in this situation? And then you can test that function. Why doesn't it return 2 when given this? Imagine a situation where it's something like doesn't allow, let's see. generates or like retrieves a user from a database. Get user retrieves a user from the database. If I want to check that like database call logic, I probably don't actually want to involve the database. What I probably want to do is have something like retrieve from database is just.fn resolves to whatever the database would give me back. And so now when I call this like get user function and it takes in a user ID and a retrieve from DB function, when it calls it, I don't need to worry about the actual logic of how it gets something out of the database. It's a promise and it resolves to that object. Maybe that's all. That helps me isolate all of that from what I'm trying to test in this get user function. Or yeah, John's example was great. I don't know what the function is. Somebody else is working on that part of it. Assuming they give me the right value back, can I move on with my life? That's sort of what spies are about. Questions?
So I see the line of code here that brought in the functions from index.javascript, but when I put that into VS Code to try to work it with the test spy practice assignment, it doesn't like me at all, and I don't know what to do about that.
Are you using the, well, for this lesson, just stick with Code Sandbox, but
oh yeah, for that one I am. Like I have
Okay.
Code Sandbox here to follow along, and then I was like,
Gotcha.
I remembered that one of the things it kept telling me was wrong was my import, and
Sure.
it didn't look anything like this. But
So it might be
does
this require. So require is common JS. When you're doing pure node, this whole thing is pure node, no browsers involved. That's why we have to use require instead of import for this one. If you're using parcel in the browser, parcel will let you do this with import export in the browser. But you have to be using parcel. You can't use light server or something like that.
okay.
And we had a question in the queue about that like yesterday or the day before. We walked through like all the finer points of that.
Okay.
Other questions so far?
So when it's testing this, is it testing it through each of the items that are on the index page, or does it specifically target map for this function?
So let's like, if I take out all of the test specific stuff, fundamentally, this is all that's happening. I'm calling this map function that I defined in index. I'm passing something into it. I'm passing in the two things that it needs. Ta-da! So the things that it needs, one of them is just a hard-coded value. The other one is this magic spy. And then so yeah, just that, other than the spy here, it's just regular JavaScript code. And then what we get out of this expect assertion is if that's not true, this will throw an error. This is the test runner. Its whole job is to just tell you everything that threw an error. But that's how it's getting map in particular. I imported all 5 of the functions in there, but this particular test is just testing that map, when given these 2 things, evaluates to that.
Yeah, so it's basically like you're just calling map right there.
Yep.
So that's how it knows. Okay.
That's it.
In a real world application, your const there of single item array, would we be able to extract something from our JavaScript and put it there, or do we make those up separate from our JavaScript?
You want to make them separate from your JavaScript because this is black box testing. This is some function called map. All right, how does it work? Well, if I pass in 1 and this function, I get back 2. How does it do that? I don't know. It's a black box. That's part of what's powerful about the test, is the test doesn't know any of the implementation details. It doesn't know any of this stuff. All it knows is that when you give it these inputs, it gives you this output. That's the purpose of unit testing.
If you accidentally name it the same thing as something in your index file, will it mess it up?
Nope, because scope.
Okay.
These are different modules. Other than like, I can't name it map. I can't name it filter because that's what I imported in. But even that, I mean, there's ways around that too. I could say const. So if I make these let, I do const my map copy equals map, and then I set map equal to anything else. Like I can do stuff like that, but I don't have to worry about anything in that index.js file because they're different modules, totally unrelated scopes. So like inside of this map function, like transformed array, that doesn't even exist outside of the body of this function. So I can certainly use transformed array over here in this different module that has that's in a different scope. Yeah, you should be able to test this stuff without even looking at the implementation. Great question. What else? Okay, let's take a look at one more. So let's say, okay, so that was a single item. What about something with 2 items? Or like in equivalence partition terms, we may say that like an empty array is a partition, an array with 1 thing in it is a partition, an array with multiple things in it is a partition. So we might say when given multiple items. So like 1, 2, 3. All right, well in this case, every time this transform gets called, this is multi-item array. So if I do this, this one isn't going to work because this one should be 246. Womp womp, it just got 222. So way around that. is to chain off of that. So this is going to be mock returned? Mock return value once. So the first time it's going to be 2. Second time it's going to be 4. Third time it's going to be 6. Passes. Didn't have to write the logic for how it did that. Just assuming whatever transform gets passed into this returns 2, 4, and 6 when you call it. Does it end up evaluating this entire expression to an array with 2, 4, and 6 in it? No logic in any of this. Nowhere that we can really screw something up. Questions about that before I cut you loose on filter?
Mine isn't running this test.
Did you save your test file?
Nope. God, that's so annoying. Yeah, it's fine.
Excellent.
So I've got like my const transform array is angry at me. Like, and I don't know why.
Let's take a look. All right. If you hover over the red line, what does it say?
It's that right there.
Ah.
I see it. My bad.
Hey!
All right. Stop.
Love it when it's an easy one.
Yeah.
All right, let's take 5 minutes. I want you to try to write these for filter. So think about, what are you going to pass into filter? What does that function return? It's not the same thing as what happens with map. See if you can figure out how to write at least one meaningful test that asserts the behavior of filter. 5 minutes on the clock. Go for it. There are 30 seconds. All right, pencils down. Give me a thumb scale. How did this go? Are you able to get some tests going with Spies? A little bit, not so much. A little bit, not so much, not so much. Yes, no, yes, no, maybe. All right, so let's talk through it. Try starting with the black box. So if I have a black box called filter, what could I pass in and what would I expect out of that that would give me some confidence that it works? So maybe if I pass in 1, 2, 3 and an is even function, I get back 2. That would give me some confidence that this works. Or if I passed in an array of objects that had like an isActive property, I only get back users that have like a true isActive property. So to write tests for that, I might go filter returns only even numbers when given an array of numbers and an is even function. Okay, so, oh no, I'm looking at the blank screen again. Arrange, act, assert. What do I need to get this test going? Well, I need the inputs. So, number array is 1, 2, 3. And then I need a function to pass into this that is even function, but if you pass a function into a test, it should be a spy. So we're going to make an isEven spy. Okay, and then what is the action that we take on it? Well, if we, filter. If I do filtered array is filter number array is even, like this. Then, time for my assertion. I would expect that I get an array with 2 back. So, I expect filtered array to equal 2. Cool, so if I run that, not so much. I was expecting an array with 2. I got back an array of nothing. So I've got 3 different times that this is going to get called. So I can chain off of that and say like mock return value once. The first time, 1, that's false. Mock return value The second time it should be true. And the last time it should be false. So if I do that, hey, I see fields of green. You going to lunch?
Yeah, you want to meet me somewhere?
Yeah, sure. Where do you want to go?
I'll text you.
Okay. Cool. So I used a spy and I mocked the return values for false, true, false. Now I didn't need to write the logic of how it figures out how to make something even. Because if I do is even, oops, come on. Takes in a number and returns number modulo 2 is 0. Okay, where's the test for that function? How do I know that I did that instead of accidentally assigning it to 0? Or what if it's not even? What if it's every third one? What if it's every third one offset by 1? Like, you can imagine situations where that logic gets out of control pretty quickly. So instead of doing that, I'm not worrying about that logic. I just want to make sure that filter works correctly if it's given the right things. I don't need to worry if the right things are the right things. So I mock all that out. All right, what about an array of things, of users, and I want to filter out everybody who who's not active. Maybe I say filter returns only active users when given an array of users and an active check. This ends up being basically the same thing. Maybe I have an array of objects in here. And one of the cool things about tests, we only need to put the stuff that's important for the test in there. So we could just put is active true, is active false. Maybe I want to put something in there to help me identify it in the test results. Okay, so there's my arrange. Well, and then this is like my isActive function. So that's going to return back twice. First time it should be true. Second time it should be false. And then my, like, let's see, this is users array. Filtered users array. So there's me setting up the test. This is me taking an action. And then I want to assert that this equals this. Ta-da! I didn't see it break. Ta-da! That's the idea of spies. If we're passing something in, don't write the logic for the function. Use a spy to mock the response. Stub it out. The less logic in your test, the more reliable your tests are. Questions? All right, one more and I'll let you go. So for each is a little bit different because it doesn't return anything. Zoinks! How will we live with that? Well, what we can do is make action a spy and then assert that it got called. So we could say like test for each calls a given function with each item in an array. So that's the thing that I want to test. But this one, the black box is kind of different. I'm sending a spy into the black box and something like, I don't know, console log. Or I'm just going to say log. That doesn't actually return anything. That has indirect output. So what I do is when this spy goes in, stuff happens with it, and then I like exfiltrate it out and go, hey, what happened? That's why they're called spies. They go into the black box. You don't know what happens inside the black box, but you can inspect the spy and like interrogate it about what happened. So this might be something like, I've got a single item array. And I've got an action, and that's going to be a spy. It doesn't actually need any behavior, as I'm just going to assert that like that the action got called. So that's my arrange. My act is to call for each with single item array and action. Notice I don't even need to save it into anything. It doesn't return anything. Why would I? But when I call this, I'm guessing that action got called. So now I can assert it. I expect action to have been called with 2, 1. That's interrogating the spy about what happened on the inside, man. Saw a lot of shit down there, man, but one thing I know for sure, I got called with 1. It's pretty much Spies in a nutshell, man. Any last questions about him? It's probably the trickiest thing that we'll do with testing. Looking through the list. Yeah, that's it. That's the hardest thing that we'll do with testing in this program. If you can wrap your head around spies, I think you're in pretty good shape. All right. That's the show. Have a nice lunch.